So, regardless, you don't need to hear my life story, but anyway, that's just why nothing got really done. So I've went ahead, and so today we're going to do a couple things. So first we're going to start off just by talking about the assignments I just posted, and then we're going to take a look at the first quiz, which will go over content from last week. And that will give you an idea of how those quizzes run. I'll have these quizzes for these two quizzes we'll do. These 2 or 3 quizzes we'll do later in either on Thursday or next Tuesday, or maybe one of them in lab. I'll let you know. But you'll notice that I posted 2 assignments, week 2 and week 3, in terms of content for this class as well as basically every other class. A lot of classes don't really like to give you a whole lot during the second and third week. Not too much, right? Nothing like utterly epic in scope yet. I don't know, unless I'm wrong. Are there? No? Okay. So, we're still dealing with. So this is actually a perfectly good time for this assignment. Extra credit. Why not take the time to learn to teach yourself regex? This is 10 points of extra credit, which will just be added straight on top of your grade. The way this is computed is that this assignment is worth 0 points, and then I put a 10 in out of 0, which means that basically that gets added to the overall average number of points, which, yeah, so that helps. Anyway, and it's extremely useful skills. You'll be using this file, okay? Now this is a dictionary file, which basically contains all the words in the English language. We'll be working with this file a lot, and last semester I had an issue with a student discovering the Scunthorpe problem, which, if you don't know what that is, look it up. Scunthorpe. Which it's a problem which basically certain names, like the town of Scunthorpe, or Scunthorpe rather, I think it's Scunthorpe. Certain places like that, as well as certain names, are basically filtered out of certain, like, email. You can't use that as as a TLD because it's filtered out for certain strings that are like 4-letter words. So that's a roundabout way of saying that basically you've got some words in here that are not necessarily the greatest, but because it's got every single word in the English language. So just a heads up there. This is, and I mentioned this because I did have an issue with that. So just be aware of that, especially later in the semester when we deal with Hangman. Anyway, this is every single word in the English language. I'll talk more about the Scunthorpe problem later when we get there, but it's a fairly interesting problem, and it's not one, and there's no real good solution for it. So this is the regex dictionary. So for first assignment, I want to basically use regex to kind of answer these questions. Like, I like animals. How many words contain the word cat or dog in them? So basically go through the file and count them out. Some of these, easy enough that you don't have to use regular expressions, right? How many 4-letter words, right? That's just checking length of 4. How many words end in ing or ion, right? Another method. Okay, but then we get into interesting things like here, which are a bit more problematic. How many words contain a Q not immediately followed by a U? How many words contain no vowels? How many words have 2 vowels in a row? How many words have at least 2 vowels? Right? I have a link, by the way, to a regex builder over here. There's a lot of good online tutorials for doing regular expressions, but they're worthwhile to learn. I might go into detail more of them later on, but it's worthwhile to learn about regular expressions. Let's see. Next is more regex, like what's the difference between dot star slash. Make a regex that matches certain things. Yes. Okay. So this is just the second page. Okay. We only have 2 pages for this. Okay. So in other classes, I have this as a much more. I I have more when it's an actual homework versus the extra credit. So this is a good chance to learn regex, but regexes are extremely powerful. Since there isn't too much, I can kind of show you what I mean by that. Like here is, so my classic story that I like to talk about regular expressions is comes from the 2016 presidential race. Actually, this part came from the 2015 portion of that race in the giant Republican primary that during the build-up to it. Specifically, right during most of the time, Florida Governor Jeb Bush was looked at as the front runner, and he led to a lot of fun memes. But anyway, Jeb Bush email. So anyway, this is the, all right, so here we go. So in let's see. Yeah, emails, personal info. Now this does have a point, right? Here we go from The Verge. Just because of the first link, Jeb Bush dumps the emails, including social security numbers of Florida residents online. So one of the things that he did during his campaign was that he wanted, and as assignment governor, is that he tried to be very transparent, and he was one of the first governors to set up an email address, right? He was the governor for a while. So you could email him, and he took the time, or at least the staff took the time to answer these emails. Now, of course, if you're emailing the governor for help with trying to get something expedited with a state agency, or maybe having a medical issue that's with Medicare or Medicaid, then it's not too unreasonable to expect that basically the person sending you the email might include their personal information, right? In here, right? RE, here's my social security number, right? Blanked out. Having an issue with basically getting kid life-saving medication or something. Anyway, contacted, please step in here, right? So anyway, your email, right? Florida's freedom of information laws are very broad. So actually, everybody knows about the Florida man meme, right? This is actually less of a result of people from Florida being crazy, although I don't know. And more to do with the fact that basically the freedom of information laws in Florida are actually very generous, so it's very easy to get all those juicy details on crazy people and their shenanigans in Florida. So it's more available, gets more reported, and boy does it sell clicks, which is what you need. The state of Florida is a news business these days. Anyway, so sending this, there was this disclaimer that hey, if you email me, that basically these could get disclosed. So anyway, in an effort for transparency, he released all his emails, and did not redact any of the social security numbers. So the reason I bring this up is that social security numbers, right, if you're trying to do just a find replace normally, that can be a tricky thing to find, right? How do you find replace a generic social security number? And the answer is using standard find replace, you cannot. But, however, if you use regex, or regular expressions, it becomes a trivial thing, right? And this is an example of basically where I like to show that things are much easier when you know programming. So, for instance, here is a regex, a social security number, 123-45-6789, and if I accidentally doxed you, I am so sorry. But, so anyway. Sometimes people might do it like this, right, where they don't have the dashes. Okay, so with regular expressions, we can detect any of those. So we can find any digit using regular expressions. Basically, you can find anything. Like here we have hello, and if we want to look for basically world in hello world, we can just ask it to do for world. We can also ask it basically to do any val. So this will detect hello world, hello world, hello world, hello world, any of those, right? This is kind of a selection thing, which is really cool. But there's other things it can detect as well as you can say skip stuff. So for Social Security numbers, we can do something like this. /D/D/D. So digit, right? /D means digit here, okay? So a Social Security number, we can just simply say it's 3 digits, followed by a dash, followed by 2 digits, followed by a dash, followed by digit, right? And that matches any of those other Social Security numbers over there. So there's other interesting modifiers we can do. We can instead say, hey, rather than, we can say exactly, so this one's interesting. This says exactly 3 of the previous. So this is a small language, a small meta language, really. And what's cool is that basically this language is basically unified pretty much inside of every programming language. Every programming language, if you know regex for one, you can use it in any other programming language. So 3 digits followed by 2 digits followed by 4 digits. But what about these dashes, right? Some people don't use the dashes. So we can use even more characters like that. For instance, we can use the question mark to say the preceding character is optional. And the preceding character is optional. And now it matches 3, 2, 4 pattern, either divided by digits or divided by dashes, or not divided by dashes. So this kind of thing, and then you can basically, Microsoft Word, Microsoft Excel, most of Microsoft products actually do support a find function using the regex. And then, most like text editors as well, like if we open up Geany again, like here's it's just a basic text editor. So if I do find, so here find replace, use regular expressions, right? I just have to check that button, and now if I'm going to look for, so let's go ahead and type one in, 123-45-6789, and now if I do this, I can do /D/D/D /D/D dash, right? There's the Social Security one, and then what I want to do is that I want to replace it with redacted. So find, let's see, find, there it is, replace it, boom. So not too hard if you know what you're doing, right? And, this is, so regexes are also very powerful. Now, one of the things you do have to avoid is that once you learn about regexes is that they are not the be-all, end-all tool for everything. They're actually pretty low on the tier of languages, right? So you have basically at the top, you have Turing-complete languages, which are basically programming languages, which are these really powerful languages where basically do anything a computer is capable of doing. But slightly below that, you have your context-free grammars, which are basically implement a push-down automata, which is essentially a state machine with a stack on it, so something with a little bit of memory. Context-free grammars do manage to handle some amount of recursion, I think. I might be misremembering, but point is that they have some amount of memory in them, so you can count with them. Regular expressions are just state machines. You cannot count with regular expressions, or rather, you cannot count to an arbitrary amount. One of the things you cannot do with regular expressions is count how many parentheses or fully balanced parentheses, arbitrary open close parentheses in them. You need some sort of memory for that, as we'll see. So that gets into the 4000 automata level class and not something you can remember. But just simply saying that, I'm simply saying that regexes are not the be all and end all, and sometimes regexes are really a nightmare. Email regex. Here we go. This one's classic. Emailregex.com. Email address regular expression that 99.99% works. Just copy paste it into the language of your choice. And let's go ahead and see it. Come on. It's a good one. Open up. Yes, leave this page. Come on. I swear it must. There we go. The standard general email regex. Here we go. which is just a bunch of gibberish over here, as you can see. And they've got a diagram of the regex to show you how it works. Yeah, somebody worked really, spent way too much time on that. And here you go. There's the @ symbol. So this is everything before the @ and everything after the @ So yeah, that can be a bit of a nightmare.
Look at, oh my God, Perl. I thought Perl was made for it.
So anyway, these. That's regex for you. I think I've wasted enough time with that. Suffice to say, it's worthwhile to do as extra credit. Your real assignment for the week is these array list exercises, which are basically if you've done these exercises with arrays, this is just simply doing it with array lists. Hopefully you've had the chance to watch the videos by now. I'll put the next week's videos as well. So in this exercise, you're going to write static methods that use lists and strings. You're also going to use generics for here. And generics is actually the hardest part, I feel, for some of the students. I have a nice write-up on how you do generic methods over here and how you write these generic methods, right? The point being is that methods, when we write methods, suppose we want a list of certain things, but we don't know what that thing might be. Like, for instance, we want to check if this item is in this list of things, and we want the list to be of a certain type. We just don't know what that type is. But we do know that we want whatever this is over here, we want E to be the same type. So if it's a list of, we want to search for a string in a list of strings. We want to search for an integer in a list of integers. And if we're trying to search for an integer in a list of strings, it's just going to reject it outright and say, you can't do that before even trying to run it. Now, we don't know what E is. Now, if we did not have this E right over here, like we did over here, what would happen is that basically it would go, oh, you want a list of E's, the object E. I'm going to go and look where that is. There is no E. What are you talking about? And so that's what happens. Here, though, we're saying if you want a static method, and this is the key, a static method to use a generic, just basically you say this function is going to be using the static E, or the generic E. We're saying right over here, E is a generic type. We don't know what E is going to be until the user passes it in. Okay. So when do we not use the above? So if we don't use this if we know the type. So for instance, if we know we're dealing with a list of integers, we don't put any generics here, because if you put integer here, public static integer, then basically it's going to think integer is a generic type, and that's going to lead to all sorts of nonsense in that method. So that is a common thing. So only put E here if you're using those. Otherwise, if you know what type the list is, put this here. So for the this assignment, right, we've got so let's go ahead and just mark those through this. Here, uniqueness, which is going to take in a list and return true if all the items in the list are unique. All items are unique if none of them are the same. Return false otherwise. So here, right, we don't know what type everything is going to be, so we're going to use E. All multiples takes in a list of integers, and returns and an int. So here, we're not going to use E. Same with all strings of size, not going to use E here. Is permutation is going to use E. Now, I want you to go ahead and try is permutation. It's actually nasty. This program, this one is meant to be, I'm just letting you know in advance that because you're going to try it and you're going to go, ah! You know, that is kind of the reaction I have from a lot of students. Even when you know the more efficient way to do it, that runs in much more optimal time, it's still nasty, just in the amount of time. It's easy to understand, but the amount of time it takes way too long. Here, it's just a lot of work and it's a mess. So I want you to try it, and then Thursday, I want to see if anybody solved it. Otherwise, we'll go through and work through it in class together. That one, I did that last semester. So here, come to class, we'll work through 2.4 together. String to list of words. This one, Incidentally, this is our first regex that we're going to learn over here. So you can use that, the regular expression I give you in the footnote for that one. And then finally, remove all instances. So I will definitely be testing you on remove all instances, both in basically demoing and on the exam. You'll get something that will look something like this most likely, or something to remember about that. Maybe, we'll see. But here, be sure when you test this to use this example. 1, 4, 5, 6, 5, 5, 2, and then try to remove all 5s from it. If you still have a single 5 remaining, congratulations, you've fallen into the pitfall. You just need to figure out why that is. This is meant to be. This one is meant for you to make a mistake on, and then try to go back and fix that mistake and figure out what's going on there. Each of these, each method's worth 15 points. You got to use 5 of those points for each of these problems is using generics correctly. So you're sacrificing 30 points by not using generics. 10 points for neat code and properly indenting. 5 points of extra credit is available in the string to list of word function. Just read the description for that. And then to demo it, be sure to explain how you solved remove all instances. There's basically 4 common ways students do it, based on so I'll be interested in seeing which ways you did, and then I'll take a look at one of the others in detail. So I'll look at 2 of them. All right. So the footnotes are your friend. All right. So with that said, let's go ahead and take a look at our first quiz. So our first quiz we're going to go is the OOP quiz. So most of my quizzes are behind a passcode, so you can't take them unless you are actually here. If you miss the quiz, come by to me during office hours, and I'll give you the quiz. And I'll give you the access code. Because they're meant to be basically participation grades, but sometimes you have to miss stuff. All right. So the access code for OOP for the OOP quiz, the object-oriented programming quiz, is OOPS. OOPS. They are generally pretty silly and very weak passwords, but that is sufficient. So here, go ahead and load it up on so you can load it up on your laptop or on a phone if you don't have a laptop with you, but it looks like everybody has it. And I'll go ahead and preview the quiz just so I can show you guys the way it looks. So go ahead and get the quiz loaded up, and we'll take the quiz. But basically, you'll see that these are multiple choice questions for the most part. True or false over here for this one. And then question 5, typically what you'll see in these quizzes, like over here, what has 4 letters, never has 5 letters, and sometimes has 9 letters. And that's worth 5 points. There's one option which says that wasn't a question, which if you think about it, it's not. What has 4 letters, never has 5 letters, and sometimes has 9 letters. So, anyway, but typically there will be some kind of thing over here that is worth 5 points or something, or some amount of points that you just get as part of just for coming in and taking the quiz. Other things will have you arranging code in a certain order, and that will give you points based on how many of those lines you got correct. But generally, it's pretty easy to get. If you take the quizzes, you're pretty much gonna get, like, if you're actually doing the effort and paying attention, you're gonna get 80, 90 in the quizzes. I rarely see people below 90 in the quizzes. Mass majority of them get all the points in here. So go ahead and take the quiz. And then if there's an error in there, let me know so I can fix it. right. So, has everybody been able to finish the quiz? Anybody still working on it? Fairly easy and straightforward for this first quiz, and that's generally the way the first quiz will work. So now that you know there's going to be quizzes this upcoming week on generics and wrapper classes, as well as ArrayList concepts, basically this upcoming Thursday. If you haven't had the chance to watch the videos, now really is good incentive to make sure you watch those videos. So, all right. So with that, we are going to go ahead and I'll go ahead. You can demo your code to me. I can help you out and stuff. Anyway, hope you had a really good weekend. Also, don't go to Florida for at least tomorrow, right, or tonight. So, because chance of massive windstorms.